Good morning. I'm Merrill Christensen, Chair of the Department of Nutrition, Dietetics, and Food Science. We welcome you to this seminar today that we've been looking forward to for quite some time. We'll begin with an opening prayer by Chad Hancock, following which Dr. Laura Jeffries will introduce our speaker today.
Our Father in heaven, we're grateful for the chance we have to gather together for this seminar to hear from Dr. Van Eenennaam. We ask thee to bless her, that she'll be able to communicate her message and information with us effectively. We're grateful for the many learning opportunities we have here on campus, and we say these things in the name of Jesus Christ. Amen.
Well, I'm pleased to introduce our speaker today, and as has been mentioned, we've been looking forward to this for quite some time. Dr. Alison Van Eenennaam is a cooperative extension specialist in the field of animal genomics and biotechnology in the Department of Animal Science at the University of California, Davis. She received a Bachelor of Agricultural Science degree from the University of Melbourne in Australia, and both an MS in Animal Science and a PhD in Genetics from UC Davis. Her publicly funded research and outreach program focuses on the use of animal genomics and biotechnology in livestock production systems. Her current research projects include the development of genomic approaches to select for cattle that are less susceptible to disease, and the development of genome editing approaches for livestock. She has given over 500 invited presentations to audiences globally and uses a variety of media to inform general public audiences about science and technology. She frequently provides a credentialed voice on controversial scientific topics and has appeared on national media, including The Dr. Oz Show, NPR, Science Friday, and the Intelligence Squared debate series. Recently, she appeared in the IFT-funded documentary Food Evolution. A passionate advocate of science, Dr. Van Eenennaam was the recipient of the 2014 Council for Agricultural Science and Technology Borlaug Communication Award, and in 2017 was elected as a Fellow of the American Association for the Advancement of Science. We're happy to welcome our speaker.
Thank you very much, Laura, and for everyone for coming. I've given over 500 speeches. It's the first time I've ever had a prayer said for my talk, so I hope it's going to go really well today. So I'm going to talk today a little bit about biotechnology, a little bit in terms of the debate around biotech, and then a little bit about some of my research. And I know you may not be a particularly agricultural audience, so I want to make sure that I'm kind of explaining it at a level that everyone can understand. But the reason that I am in the area of science communication is working in animal agriculture and agriculture in general. I think we have been dealing for many years with what I might argue is fake news. And there are certain issues that keep rising, and I feel like often I'm playing a game of whack-a-mole in terms of what particular issue I'm dealing with on that particular day. And so today's mole is going to be the GMO discussion. If you type GMO into the internet, that's what you're going to pull up, some terrifying images playing at the very core of your being, that somehow this is going to damage your children or give them autism or cancer or make them infertile. And, you know, as Abraham Lincoln once said famously, don't believe everything you read on the internet just because there's a picture with a quote next to it. And I really like that meme because it just captures so much. And, you know, as a scientist, when I see those types of things, my gut reaction is to come back and say, well, what does the data say? And if you go to all of the major societies of the world, you can have a look at what they have concluded, and the scientific societies to me are a place, I believe, if you can get a group of scientists to agree on something, then you really do have something that's true, because it's hard to get a concurrence. And when you have the World Health Organization, the National Academy of Sciences, the American Association for the Advancement of Science, the American Medical Association, and the European Commission all saying the same thing, which is basically that there is no science associating this particular breeding method and the approved products with any health concerns, then for me, that's good enough. And seriously, it is every major scientific society in the entire world that has this opinion. So, given that's the case, why is this the case? So if you look at the top there, the gap between where scientists are around the safety of genetically modified foods and where the public are, the red dot, is a 51-point gap. How did that happen? There are other controversial politicized topics, climate change, vaccines, and the gap is not as great as it is around this particular topic. And I think it's an interesting scientific question. Well, how did that happen? How did the public get it so wrong? Where are they getting their messaging from? And I think it's interesting to look at the vast majority of all the scientific societies that think this versus this one group put together fairly recently, as distinct from the scientific societies, which have been around since the time of Lincoln, put together to put out in a pay-to-play journal, an opinion of about 200, mostly social scientists in Europe, a consensus document from this group of individuals that have been solely put together for the purpose of putting together a document that says that there is no consensus on the safety of this particular technology. You would think that would get laughed out of the building because you've got this group versus every major scientific society in the entire world. But what happens with the current kind of climate of social media is that this then gets picked up by groups where this agrees with their confirmation bias, or maybe they have a marketing advantage to promoting non-GMO, and so they're trying to mislead people. And you'll see these types of images on the internet where no scientific consensus on GMO, and there's invariably a tomato with an insulin syringe associated with these memes. I don't know why these poor tomatoes, if they're diabetic, I feel for them, but that is not how we do genetic engineering. It doesn't involve insulin syringes of any sort, but that meme and that appeal to emotion, I think, you'll see it on all of the fear-mongering around this. And the hope is that the public will get the impression that it's like, oh, wow, the jury's really out on this. You know, we just don't know. And better to be safe than sorry than don't know. Because, you know, science has been wrong before. Look at the tobacco companies. And you'll always get this kind of drawing of other examples that have absolutely nothing to do with this breeding method. But, you know, science was wrong once, therefore science is wrong forevermore. And the hope is that you'll get this this thing called the spiral of silence. And I'm sure you've been in situations like this. I live in a very liberal town, and so a lot of my colleagues don't know much about agriculture, and the mums will get together and they'll be saying something about, you know, the value of a non-GMO product, something, and I'll be there and I'll be like, do I want to be that mum at a cocktail reception that's like, oh, you don't know what you're talking about, let me tell you about the science? Or do you just go, I'm going to let that pass? And that happens a lot, I think, where these incorrect ideas get within a little social bubble and there's no one there to correct them, or no one that wants to have a spine to stand up and say, no, this is actually wrong. And so it kind of keeps on going. And then this gets fueled by groups who have an agenda. So Greenpeace, for example, then puts together this meme that says there's no consensus on genetically modified food and environmental safety, according to this little group of ENSER. And I think it's kind of amusing. As a scientist, I'm pretty into precision. And if you're going to put out a meme where you're citing the one group that agrees with you, you could at least get the acronyms spelled correctly. And so we haven't even got the European Network of Scientists for Social and Environmental Responsibility, they've got it incorrectly spelled on their meme, which I just think is ironic on so many different levels. But you know, this information deficit model is kind of how science-minded people tend to take to educating the public. If only we'd educate the public, then they would understand, and we'll just impart a whole bunch of blah facts on them and they'll magically change their minds. It's been spectacularly unsuccessful forever, but it appeals to scientists because that's actually how we tend to make decisions. We are very evidence-based. That's the definition of science. You have a hypothesis, you test it, the data informs your opinion. If you're not doing that, you're a really bad scientist. But that's not how normal people make decisions. And it's sometimes not even how scientists make decisions around things where they have a particular ideological viewpoint. And the problem is not the public being ill-informed, as scientists would like to say. It's actually the scientists. And basically, you'll often hear, well, if people understood agriculture, then they wouldn't have these opinions. But the research shows that science literacy has only a limited connection to public attitudes. And instead, it's how much the audience trusts you. Are you a trusted person to convey that information? Whether you're giving the presentation in a way that's compelling from an emotional level. Am I part of your tribe? Do I trust this woman? Is she part of my kind of tribe? And how the issue is framed. And that's much more important than putting out information. It's the exact opposite of a typical scientific lecture, where you have your materials and methods, and then you present your data, and then you present your conclusions, and then you say you need more funding to do the next piece of research. That's kind of how it's set up, right? It's not at all emotional. And I think that the framing of this issue has to be changed. And so I'm going to go through a couple of examples. I'm not going to explain what a GMO is. It's irrelevant. Let me show you how this breeding method can help with problems like ring spot resistance virus. This is a virus that kills papayas. Basically, it wiped out the Hawaiian papaya industry. By using this breeding method, this public sector researcher, Dr. Gonzalez, was able to produce disease-resistant papayas that no longer are susceptible to this disease, and therefore he saved the Hawaiian papaya industry. Let me introduce you to Scott Simplot. He works for Simplot, not surprisingly. They have used this breeding method to develop potatoes that don't go brown when you peel them. That's responsible for about 30% of food waste associated with potatoes, and I'm sure we've all done that, peeled the potatoes, and you come back a half an hour later and they've all gone brown. It's also associated with higher levels of acrylamide, of interest to food scientists. Here they're using a breeding method to turn off the gene that makes those potatoes go brown. Let me introduce you to this fruit farmer from Canada. He's developed an apple that doesn't go brown also, actually by knocking out the same gene that was knocked out in the potato. So basically you can chop up the kids' apples in the morning, pack them in their little baggies, and when they get them out, they won't be brown at noon, and therefore they won't get thrown away, or hopefully won't get thrown away. Let me introduce you to this application, BioCassava Plus, or BC Plus, which aims to raise cassava's levels of iron, protein, and vitamin A to provide the complete minimum daily dietary requirements of these nutrients for people whose main source of food is cassava. This is being done by a non-profit group, the Bill and Melinda Gates Foundation, in collaboration with some plant breeders. This is a partial list of publicly funded applications of this breeding method being used to address problems associated with agriculture, be it disease resistance, be it browning or food waste, or be it nutrient fortification. You can see a range of different public entities represented here, doing things like producing disease-resistant chestnut trees, oranges that are resistant to the citrus greening disease, plums that are resistant to disease, wheat that has altered levels of anti-nutrients, and a bunch of biofortified products. Two things I haven't mentioned up until this point is Monsanto and glyphosate. And that seems to be all the GMO conversation is about. And it's so much more than that. And that discussion around that company and that application is forestalling all of these really beneficial applications from being utilized. Having said that, the existing products on the market have been the most fastest adopted agricultural technology introduced. There's been a 110-fold increase since genetically engineered crops were first brought to the market in 1996. There was 185 million hectares planted in 2016. And I think what's interesting is to look, where are these crops getting planted? And what you see there is the rise over time. The green countries are those countries that allow the cultivation of genetically engineered crops. But just because you're yellow doesn't mean you don't use them. For example, Europe is often cited as a place where they don't use GM crops. And it's true they don't cultivate them there, but they import the heck out of them to feed all their livestock industries. But I want to draw your attention to the red line, which is acreage being planted in the developing world. And actually, 90% of the farmers growing the current generation of genetically engineered crops are developing farmers, or farmers in the developing world, growing insect-protected Bt cotton, particularly in China and India. That is a crop that's protected from basically being eaten by caterpillars, and in the place of having them be insect-protected, those farmers were spraying insecticides to take care of that problem. The worldwide reduction in insecticide use as a result of Bt crops is breathtaking. It's about a 20% global reduction. And those are smallholder farmers in the developing world. Why is that never part of the GMO discussion? I think it's hard to argue against that technology that's had such a dramatic decrease in insecticide use globally. And to me, it's important that there's a discussion around this, because let's just say that we ban the technology tomorrow, as some have suggested would be a good idea. Well, let's look at the opportunity cost associated with not adopting this technology, and we can actually document what the consequence of adopting the technology is. So you can just work this equation backwards. So instead of reducing global pesticide use by 8.1%, we'll increase it by that amount. And if you look at the toxicity of the herbicides that are used now as a result of Roundup-ready crops, it's a lot lower than the pesticides or the herbicides that were being used to protect crops from weeds prior to the introduction of that. And so from a global perspective, it's an increase in toxicity of pesticide use of about 20%, and additional tillage, which is associated with increased release of greenhouse gas emissions, which is equivalent to putting 11.9 million cars back on the road, if you look at it that way. And so there's real consequences to this debate, which is being fueled by misinformation around the safety. And I think that that's a really important thing that's not being well communicated to people. And I think part of the problem is that the scientists haven't got a good handle on scientific communication. And I think that if you look at basically the available means of persuasion, scientific talks tend to be very much focused in this thinking center of the brain, where you start with your background, your supporting details, and your results. But even Aristotle knew that it's actually also important to appeal to people's ethos, and particularly their pathos, their emotions and values, to get the audience on board, especially a public audience that maybe isn't a particularly science-educated audience. And that these types of talks, where you just start with the shared values that you've got with the audience, and then why we're doing this, what problem are we solving, and then if they're really interested in the supporting details, but for the most part, people don't really care. They want to know why you're doing it and that you have good intentions behind what you're trying to do. And that's a better approach to scientific communication. Unfortunately, this is an even more effective approach. And this is the approach you'll see used by snake oil salesmen or people trying to spread misinformation around science. And this is basically an entire appeal to emotions, often by people with very little credibility or even qualifications in the area about which they're speaking, which is kind of perplexing to most scientists. Like, why are you listening to a swing dance instructor around the safety of GM food instead of every major scientific society in the world? What is the rationale there? And there's this common narrative, and I don't care if you're talking vaccines or GMOs or other controversial, there's an enemy, some big multinational corporation or maybe a company or the government or scientists, paid off shills, and they're working against everything that we care about. So they kind of bring you in as the audience as part of their peer group. I'm helping to protect you from them. And they set up this kind of conspiracy theory where they've got the magic bullet answer to go against them, and there's this real dividing of the us and them. And I think you guys might be familiar with some of these spin artists in the food science department. I'm sure you're well aware of Food Babe, who's well trained as a computer scientist, I think, if I'm not mistaken, who's worried about chemicals in her food. And Jenny McCarthy there, who's convinced that vaccinations cause autism. And these people use sex appeal very effectively. You know, that Jenny McCarthy dress would be a little strange at a scientific conference, I think. That would not usually go down too well. And really, they use that sway to emotions. And so I think that really there's a need for scientists to learn how to do it in a way that is still true to their intent and their own morals and ethics, but to be more compelling in the way that they tell these stories. And so with that background, I'll give you a little storytelling. And so I'm going to talk about an experience I had in New York City with the Intelligence Squared debate that was mentioned in the introduction. For those of you that aren't familiar with that, it's a debate 2 on 2. That's why it's IQ2, Intelligence Squared. 2 for, 2 against a topic. And every topic every month is different. So it might be physician-assisted suicide or American exceptionalism or those types of topics. And I was involved in one in 2014 on GM food. And when they asked me to do it, I was like, oh, yeah, okay, sure. I'm passionate about this topic. I think this breeding method has a lot of options. Who's going to be my awesome scientific colleague that's going to be on the stage with me? Is it going to be my friend Kevin Falter from Florida, or maybe Nina Fedorov? No, it's going to be the guy standing next to me there, that's Rob Fraley, the Chief Scientific Officer of Monsanto. Oh, good, in New York City. Oh, that's going to go well. Yeah, I can't see any problems there. Wasn't super excited about my debate partner. But then I thought about it a little bit more, and I thought, you know what? A lot of this debate is around them, that company, and herbicides and weeds and super weeds and black helicopters. Let him take all that. And that lets me argue the science and the benefit of this to people. And it really was a good framing. The other two, just for completeness, is Charles Benbrook, who was, at the time, a researcher at Washington State University, and Margaret Mellon, who used to be with the Union of Concerned Scientists. And so basically the way that this debate is set up, at the beginning they give people clickers, and you have to click in what you think about the topic. And so in this particular situation, genetically modified food was the topic. And at the beginning of the debate, there was about 32% that were for it, 30% against, and 38% undecided. This is a group of New York people that pay a subscription to go to the IQ2 debate series. So they're not particularly vested one way or the other in the topic, other than what they've heard in their bubbles. And so that was basically how it's set up. And then the debate goes, you each get 7 minutes, and then there's about 40 minutes of backwards and forwards, and then there's a wrap-up. And it's a 120-second wrap-up, 2 minutes. Not 121 seconds or 119 seconds, 120-second wrap-up. And so I prepared my debate. I've never done a debate before. And so I prepared my 120-second wrap-up. And I read it to a friend of mine who's not a scientist. He said, "You're kidding, right?" And I'm like, oh, it was just chock full of data. It was beautiful. You guys would have loved it. And I'm like, yeah, it's awesome. It's really good. And he goes, no. You need to personalize this, and you need to connect with the audience about why you care about this topic. Don't use science. Use that appeal to your common shared values with this audience in New York City, who I might not have had that much in common with, but I think everybody would like to have safe food, and I think everyone would like all people to have access to food, and I think most people want to reduce our environmental impact. I think that's a shared value of, I don't know, humanity, I would argue. And so I'm going to play you now the wrap-up from the 2 minutes, my 120 seconds. And as you hear, I'm Australian, and as the time was getting closer, I speed up right at the end so that I get it all in, but this is basically how it sounded.
This past week, the US celebrated Thanksgiving, a wonderful holiday, and we had 14 people over to our house. And as the hostess, my task was to serve a safe, delicious meal. You know the drill, keeping the raw turkey out of contact with food surfaces, making sure you cook it enough to get rid of foodborne illness, but not so much as to be dry, all whilst drinking a glass of wine, which probably added to the risks. But actually, food poisoning is a real risk, and 3,000 people a year die of food poisoning. As we gave thanks for this abundant cornucopia, the one risk I was not concerned about was whether any of the food was genetically modified. And I was serving this meal to the people I love most in the world, my dearest friends, my husband, my 2 teenage sons. Their well-being is of paramount importance to me. And as a parent, it's my responsibility to use the best possible information to protect their health and to determine what the scientific consensus is on technology. That is why my kids drink pasteurised milk and have had all of their childhood vaccinations. Sometimes the risks that concern people and the risks that kill people are entirely different. For too long, the debate over the merits of genetically modified food has focused on unrealised hypothetical risks and has been conflated with the use of pesticides. It has not addressed how GM could help with the very real risks faced by the hungry and malnourished. There are costs associated to excessive precaution. Doing nothing is doing something. During the 90 minutes we've had this debate, approximately 1,500 people died of hunger, more than all of you here in this room. Hunger and malnutrition are real risks, risks that kill over 20,000 people daily, and most of those who die are children. These are not talking points, they're people. As a mother and a scientist, what concerns me is the fear-mongering campaign against genetically modified food is forestalling scientists from using this breeding method to help produce more nutritious and sustainable food sources for millions of people. Vote yes for GM food.
So, not a talk I'd normally give in a scientific setting, but that's not my target audience in this case. It's a different style of communication. So at the end of the day, they had to click back and see what we did with that audience, and that's what the results was. Basically, we didn't change a single mind in the people that were against GMOs, but where we did reach was the undecideds. And I am of the opinion there's many undecideds about many topics in this world, and we tend to spend a lot of time listening to the people that are never going to change their mind, rather than focusing our educational efforts on the ones that have an open mind and haven't yet made up their mind. So that's a little bit of background to the GMO debate, and now I'm going to talk a little bit about my area of animal breeding. You may have noticed my dog. I don't know if you agree based on this if my dog is a good choice for me, but there is definitely a lot of alterations we've made using conventional breeding. So these are not genetically engineered dogs, but I would argue they're pretty genetically modified relative to their ancestor, the wolf. And I do think that plant and animal breeders have one of the most compelling sustainability stories of all time. And what you can see here is yield of corn over time, and you can see these inflection points as different breeding methods get implemented into breeding programs that accelerate the rate of genetic gain and increase the yield per acre. And from a global food perspective, this requirement to sustainably intensify our food, I think, is just an overwhelming drive. And if we look, we can see similar inflection points in the dairy industry, and you can see there that's not artificial intelligence, that's artificial insemination, introduced in the 1940s, that enabled all farmers access to the very best genetics, dramatically increased our milk yield per cow. And as an urban dweller, you might say, I don't care. Well, let me tell you what the actual implication of that was. In 1944, we had 25 million dairy cows in the United States, producing 53 billion kilograms of milk. In 1997, we had only 9 million. We decreased our herd dramatically, whilst increased the amount of milk we're producing. If you want to think of that just in a simple term, the carbon footprint of a glass of milk today is 1/3 of what it was in the 1950s. If it hadn't been for innovation in breeding, that we would need somewhere around about 40 million dairy cows to produce the same amount of milk that we did last year. That's a huge environmental impact. That's why I think we have a compelling sustainability story. And if we look at projected demand through 2050 with the 9 billion that are projected to be on this earth, the current rate of increase of yield is not going to be sufficient to cope with the projected increase in demand. The solid lines here for the 4 major plant species or crop species that are eaten are the projected rates if we don't do anything differently, and the dashed lines is the rate of gain that we need to address projected population growth. How are we going to go from the solid line trajectory to that dashed line trajectory. We need new innovations that will accelerate the rate of genetic gain even more. And this is plants. If we look at demand for animal protein, particularly milk and meat in the developing world, where we've got people raising out of poverty and converting from a very basic diet to one that includes some animal protein, you can see tremendous projected increases in milk and meat demand in the dashed lines there in the developing countries. And that keeps me awake at night as an animal breeder, because I don't want that to be provided by more animals. I want that to be provided by more productive animals, because the environmental footprint otherwise is very, very high. So one of the most exciting techniques that's come along recently is this new technology called genome editing. You may have heard of CRISPRs. They're very sexy at the moment. I'm not sure why they're so much more sexy than TALENs, but there are many different basically gene editing tools. They're a pair of scissors that can go and make a double strand cut in DNA, and you can tell it where in the genome you want it to make a double stranded cut. Whether it's CRISPR or TALENs or zinc fingers, it doesn't really matter. And then basically what you can do with that is then inactivate a gene that you don't want expressed anymore, so the protein never gets formed in that creature. And maybe that gene is a gene where a virus is able to access an animal, and so you produce an animal that's resistant to viruses. Or you can do, go down the left, right-hand side there, you can introgress maybe an allele from one breed of cattle, for example, beef cattle, into dairy cattle. And I'll give you two examples of that, one of which is work that's being done in my lab, to show you the types of things that you can do with this. So these are just some examples that have been reduced to practice by animal breeders. They're not in the food supply at this time, but you can see that breeders and scientists have been working on cattle and chickens and goats and pigs and sheep, doing things that are very similar to the types of things we do with our conventional breeding programs: increase productivity, produce disease-resistant animals, and then a couple of new twists. So you'll see one of the things I'll talk about here is editing so that dairy cows no longer grow horns. And that's an animal welfare trait that we're trying to target with this gene editing. So one example that I think is particularly compelling is in the swine industry, where the University of Missouri went in and turned off a protein that's the attack site where a virus called PRRS is able to access the pigs. PRRS stands for Porcine Reproductive and Respiratory Syndrome virus, and basically it's about a $600 million disease issue in the United States and something like $1.2 billion in Europe. And this basically, by turning off that protein, those pigs are no longer susceptible to that virus. You've produced pigs that are no longer susceptible to PRRS. There are also groups at the Roslin Institute working on trying to develop pigs that are resistant to African swine fever, another devastating disease that's spreading up from Africa into Europe. You'll notice every example I've given you so far, we're talking about public universities. This is Roslin Institute, University of Missouri, University of California, Davis. And that has been historically who's been developing animals and genetically engineered animals. There really isn't the big company overarching concern that was often tied up with the GMO debate as we talk about animal editing. And to me, I'm a geneticist, everything is a genetic problem, but I would rather have disease-resistant animals that are genetically immune to a disease than have sick animals that are getting treated with antibiotics or dying. It's just a better solution. And I fail to see how disease-resistant plants and animals don't fit with every definition of sustainability. Why would you not want disease-resistant plants and animals? It doesn't make sense for some production system to arbitrarily preclude disease-resistant plants and animals. I'm going to talk about some research in my lab. So we've been working using genome editing to knock out the gene that grows horns. And I'm assuming some of you haven't ever dehorned a calf, and many of my audiences, that's true. And so we created this next piece. You may have seen I'm a little bit interested in media, different media approaches to educate and inform the public. And so I'm going to show you a video we developed in collaboration with Cornell Alliance for Science. You might wonder what's UC Davis doing collaborating with Cornell. We're two big land-grant universities. We're meant to be enemies with each other and like compete against each other. If this is too big of a problem, we all need to work together on getting this information out. And so I will play this video for you.
there's a lot of differences between them. So dairy cows have been bred to be very optimal for dairy production. And as it happens, that brought along the horned phenotype. In other words, dairy cows grow horns. If we look at our beef animals, they've been bred for optimal beef production. And as it happens, Angus, for example, is a breed that doesn't have horns. And we don't really want horns in dairy production systems because the animals hurt each other with the horns and they can hurt the human workers.
A widely accepted husbandry practice that we dehorn cattle, both for the safety of the cattle as well as for the safety of the people that take care of the cattle and work with them. The way that this budding procedure is done here routinely is we will administer a lidocaine block. Lidocaine is a local anesthetic similar to what you might get at the dentist's office for a procedure that might be painful. And then we use an electric dehorning or disbudding instrument that provides heat around the horn bud to kill the cells that would grow the horn. Consumers are concerned about the way we care for our dairy animals, and they expect us to do a good job of providing care and being concerned about animal pain when we have to perform procedures. So I think it's important that we keep those factors in mind and do the best job that we can to try to minimize pain and discomfort.
In collaboration with a company called Recombinetics, who had a vision to try to use precision breeding or genome editing to introduce genetics from Angus cattle to the Holstein dairy breed to produce dairy cattle that don't grow horns. And so we haven't altered anything about all of the genetics that makes them great milk producers and you know, all of their Holstein genetics is still in place. What we've basically done is a very precision technique of just introducing one trait that we want, which is polled or hornless, and we haven't altered the rest of the genetics.
With the change of technology, it looks like that we can achieve the goal of having calves born without horns and not have to give up the genetic capability of those animals. So it looks like a win-win situation. We've still got very productive, efficient dairy animals, and we now have the opportunity or possibility of no longer needing to dehorn or disbud dairy calves.
So you can see that didn't go into a great amount of detail as to how we do gene editing, because that's really not the purpose of that video. But the question that I have is, are animal breeders going to be able to use gene editing to make disease-resistant pigs and polled dairy cows, or is it going to go the way of GMOs? And what do I mean by that? How many approved, commercially available, genetically engineered food animals are available on the market in the United States? Any answers? 0. That's why I care about this debate, because it's stopping us from using these technologies. And for that reason, I participated in the Food Evolution movie that Laura mentioned earlier. I'm going to play you a little trailer of that movie to give you a little bit of a taste, because it is going to be showing here on campus at 3 o'clock today, and I think it's a pretty cool movie.
The survival of our species has always depended on advances in agriculture.
Climate change is going to scramble this how are we going to feed the world debate.
This is all about companies.
This is about money. This is about power.
It's much easier to sell fear than it is science.
If you don't have food, then you're going to steal, you're going to kill someone.
So, how do we make the most informed decisions about how we feed ourselves?
The 3 most terrifying letters in the English language are GMO. I wondered how many people really know what they are. I don't know.
I know it's bad.
Genetic engineering is a modern form of breeding.
The goal is to add useful traits into food. I am concerned about some of the health issues related to GMOs.
More colds, autism, susceptibility to hepatitis, cancer, HIV.
There's absolutely no proof to a health hazard.
never trust one opinion. You look at the consensus of experts.
I don't think the genetically modified organisms are dangerous.
You're either going to be GMO or you're going to be organic. They cannot coexist.
If this is an organic planet we're going towards, you would see all the rainforest destroyed just to feed the current population.
This is something I'm going to look into.
Some people can say wild and crazy things.
I trust the social media more than most medical doctors, more than the CDC, more than the FDA, more than the EPA. I don't need scientific study.
Things like that.
We humans are wired to make our minds up and that's it.
We make decisions based on our gut. When was the last time you changed your mind?
Our intentions were honourable. We were trying to protect the future of the planet and the health of our children. It begs the question, how do you know the GMOs are the enemy? What if we got it wrong?
The good thing about science is that it's true whether or not you believe in it. You see, that's the...
So I encourage you, if that looked tantalizing, to come along this afternoon, and I'll have our Q&As afterwards, and I'm happy to answer any questions. It's not unusual for technological innovation to face resistance. It is perhaps novel to have it in the social media era, which makes it more problematic to get the correct information out there. But this quote looks like it might be talking about genome editing or maybe genetic modification. Does anyone know what this quote might be associated with? It's unknown the long-term health consequences, the studies aren't adequate, it's not going to be available to small farmers, it's going to decrease product acceptance and consumption. Introduction of the pasteurized milk ordinance in 1924. So we're not unique, it's been around a long time, so it's just, I think, a little bit harder to deal with the social media kind of aspect of education. So this is the only approved genetically engineered animal that's not available on the market due to congressional riders on the budget bill to prevent it from being sold, a little bit of political interference in what should be a science-based regulatory approval process. Basically, it's a fast-growing salmon. This is a transgenic and its sibling. I'll let you guess which one's carrying the growth hormone gene. It gets to market weight in half the time. It doesn't get bigger, it just gets to market weight in half the time. And if you know anything about animal production, 70% of production is feed. If you can get to market weight in half the time, you basically reduce the amount of feed, or the feed conversion ratio is improved. And it took from 1989 till 2015 to get it approved. It's almost a quarter of a century because the FDA regulates genetically engineered animals as drugs. And so they consider that the recombinant DNA construct that's in the fish, in this case it was a growth hormone from the Chinook Pacific salmon, they consider that alters the form or function of an animal, and that's basically the definition of a drug, and therefore that recombinant DNA is a trigger for a new animal drug regulatory review. So you have to go through all of these studies showing whether your drug is safe and whether it's safe for the environment and safe to eat and that it's stably transmitted over multi-generational studies. It's quite a complicated process, and it's really designed for, I don't know, dog wormers. It's not really designed for DNA because we're all made up of DNA, right? I mean, that's why I look like and you look like you look like. Yeah, DNA does alter the form and function of an animal. That's actually the definition of what it does, right? And so it's a little bit of an awkward definition. And the hope was with the new genome editing that because you're not introducing recombinant DNA, there is no DNA coming in from another species, or sometimes you're just turning off a gene, you're not introducing any DNA, that it wouldn't trigger this regulation. But 2 days before the current administration took office, the FDA released a draft guidance that considers all animals' genomes that have been altered intentionally using modern molecular techniques are drugs. And so if I make a single base pair deletion using my scissors, my editing scissors, the lack of that base pair is a drug, and that animal is now going to have to go through a new animal drug regulatory evaluation. What about my little guy? So he has a piece of DNA from Angus at the allele where he would have grown horns, so he doesn't grow horns anymore. How is that a drug? I think we've sequenced these animals and there's no changes in the genome other than what we intended to do, which was basically turn off the horned gene. You know, in my opinion, he's not a drug, he's a polled Holstein, you know, and it's just that simple. And so we have this kind of crazy regulatory proposal on the table now, and it just doesn't make sense to me. This is a polled Hereford. It's a naturally occurring, his genes have been turned, or its genes have been turned off too, just by nature or a spontaneous mutation. That doesn't need to go through regulatory because humans didn't intend for that to happen. But if I intentionally introduce it into a Holstein, then that's going to trigger a multi-generational regulatory evaluation, and the generation interval of cows is 2 years. So that's at least a 5 or 6 year regulatory process for not growing horns. What's the drug in that case? It doesn't make scientific sense, and I think we as scientists have to really stand up for this. And I'm going to finish with something that my graduate students put together because I make them do scientific communication that kind of touches on the promise that they see for gene editing in our food production systems.
I got this laser inside my scope. I see them cells to edit when I turn it on. All through our research, we make our cuts. We're editing genes, no limit what we might achieve. I got that iPad in my pocket. We got those lab shoes on my feet. In that thrill of innovation every time. Ooh, I can't take my lens off it. Getting high fidelity. We gonna like the way we use it. So don't stop it. It's out the research. Everyone knows. No way to feed when the populace grows. When we edit, well, it already shows. Just a legend, just a legend. We can't do any advance. I'm like, well, I might change the world. Just advance. All these things I could do to those advance. Yeah, ain't nobody stopping to do the medicine. I can't stop to be there. Just advance. It's not gonna be there. Just advance. Ooh, it's nothing magical. There is a method and a reason it's feasible. I need a theory and two controls to test my idea, no bias and a genome. I got that iPad in my pocket. We got those lab shoes on my feet. In that thrill of innovation every time. Ooh, and include global problems with that sustainability. You know, like the way we solve it, so stop it. It's out the research, everyone knows. No way to feed when the populace grows. When we edit, well, it already shows. So just imagine, just imagine, just imagine.
Frank, can you stop?
All right, thank you. I'm happy to take questions if anybody has some. Yes? Oh, the syringes? No, it's a long and complex history, really, as to why the whole concern around GMOs started off. It came onto the market at a time when there were some other food scares, BSE particularly in England, distrust of corporations around cigarettes, and then there became an industry that realized that they could market that fear and sell competing business products. And so now there's a literally multi-billion-dollar natural foods industry that is really funding a lot of the groups to put out misinformation. So originally it started kind of, I don't know, organically. I don't mean that in the organic production sense, but it happened that way, and now it's become a business machine. And you can see them starting to target genome editing, which really worries me. That's why I'm pretty passionate about trying to protect it. I think I saw your hand next. The relationship between genetically engineered organisms and genetic mutations in humans. So, none. I mean, the genetic engineered food is just, it doesn't have anything to do with human mutations, but I mean, we have mutations all the time, right? That's the basis of evolution and why we all look different, because our cells are undergoing mutations every cell cycle. But there's no, I'm not sure if you're asking from a cause and effect perspective, if there's anything to do with mutations in humans caused by GMOs. No, there's no science that supports that breeding method is associated with any health concerns, and there's no biological plausibility as to how that would be associated with mutations in humans. Well, I guess that I would refer you to the National Academy of Science's recent study where they looked at all of the literature that exists around GMOs, and particularly they looked at populations that aren't consuming GMOs versus, for example, Europe versus here, and there is no change in, there's no difference in trends. There's no, you see the activists say, oh, cancer's going up. Cancer's going down in both places, and so there's really there's no correlation there, and there's just no evidence that there's any associated health effects. And so I would really recommend that Academy. They tried really hard to make it so you can get on their website and read little simply comprehensible aspects of the study that they did. But that report was released in 2016, and really they set out to look at the entire world's data, and they found no evidence supporting any indication of a safety concern or any association with mutations. I don't know who to look at next. I'll go with you up the back. Yes. Yep, that's you. Do I have any thoughts on labeling? You know, I guess I'm kind of sick of the labeling debate. At this stage, the little butterflies on so many things, it's effectively, we have the no labeling, you know, the non-GMO labeling. You know, historically, food labeling is reserved for something that's important as it relates to the attributes of the food, so either nutrition facts or contains peanut allergens. We haven't had mandatory labeling for production practices. If you want a particular production practice like kosher or halal, that's been a market that's voluntarily labeled for that differentiated product. And we've kind of got that now with the non-GMO project. But mandatory labeling is a law, and it comes with a lot of expenses, because if it's incorrectly labeled, then you get sued. And tracking, for example, oil, canola oil, doesn't have DNA or protein. There's nothing to track there. So labeling canola oil would mandate entire supply chain segregation and traceback. And just the costs of doing that, or the grain silos of America, keeping track of which ones happen to have been genetically engineered or not, it's a big logistical nightmare. And I think that's my concern, is just the costs to the food supply for people that don't care. You know, usually it's that the value-added market are the people that care about whatever it is, cage-free chickens or whatever. You don't make everybody else label non-kosher. You know, you make your kosher ones labeled, and then the rest of it doesn't have that. So I think it's, again, I think a lot of the groups that are pushing labeling want it as because they've created this fear, and they see it as a market advantage for their products. So that's my cynical opinion. Yes? Yes? Well, so what's the difference between gene editing and genetic engineering? So genetic engineering traditionally, in old-fashioned genetic engineering, has brought in a gene like the Roundup resistance gene or the Bt protein from bacteria, in this case, into plants. So you've brought recombinant DNA, a gene from one creature into another. With editing, you're not necessarily introducing novel DNA. You might just be turning off a gene that exists in the species, like polled, so they no longer grow horns. There's no new DNA in there, there's no new protein. It's just basically, it's as if a normal mutation happened. Well, it has happened. That's why Angus don't grow horns. It's a naturally occurring mutation that makes horns not grow. So it doesn't introduce novel DNA. And so, you know, that was the idea. In fact, Europe just had a court decision today that suggests they're not going to consider animals or plants or animals that don't have novel DNA to be genetically engineered. So there is some idea or that regulations in other places might not consider them to be genetically engineered. I think, yeah,
a great discussion, but there's a class here.
Oh, okay.
But we'd love to invite you to, it looks like a lot of you still have a lot of questions, and so we'd like to invite you to come to the documentary film, Food Evolution, that was mentioned. And it's at the Lee Library, and at 4:30 we'll have a Q&A session. And then Dr. Van Eenennaam will also be speaking tomorrow in the Marb at 11, and there'll be another opportunity to ask her questions. So we'd like to thank her again for coming, and thank you for coming as well. Thank you. That was great.
Good.
Yeah, too bad we had to cut off those questions.